Santorini is really shaped like a letter C. Akrotiri, the site of the dig, is down here at the southern part of the island. While we were in Santorini, we stayed with the Nomikos family. One of their projects is supporting the restoration of Akrotiri. I started to talk to the younger Peter Nomikos. He knew I was a computer scientist, and he said to me, "Do you think there's any possibility of using computers to reconstruct the frescoes?"
And we said, yes.
So these wall paintings depict everyday scenes out of their lives, and because of that, these wall paintings, they are a unique window into the time of that civilization. The archaeologist's current system is, of course, a manual one.
There's a gigantic table.
Just filled with little fragments of plaster.
It really looks like the world's largest jigsaw puzzle, and you've got a group of conservators who come in, and in addition to preserving the pieces, they try to find matches. And it feels like a project that will never end. I mean, the number of pieces is mammoth.
One of the things that we found very impressive is that the conservators actually know all of these fragments by heart.
On our first visit to Santorini, we spent basically all time on figuring out how they work at the moment. What we want to do is to incorporate the conservator into that search for matches. We try to mimic as much as possible from their mythology, in order also to reach a point that the conservators actually can use our software as a tool in their usual process.
Once the fragments have been excavated and stabilized by the conservators at the laboratory, we take over by assigning each fragment an ID number.
And simply click a button and wait for it to start scanning.
The 3D scanning consists of placing the fragment on a 3D scanner and capturing the shape of the front and back surfaces as well as the edge surfaces. So use a flatbed scanner in order to capture very high resolution, essentially photographs of the front surface.
So when we want to find matches between the fragments, we look at the edges of the fragments, at the shape. And so what we're doing is we're essentially trying to position every possible relative position of every pair of fragments. And we're seeing which ones fit together very well. And in fact, the conservators, when they're finding matches, are often doing exactly the same thing.
This is what we call a tabletop, which is a surface with a millimeter grid on it, where you can actually place fragments that we actually scan. So these are original Santorini fresco fragments. You can actually visualize the gap between those two. So currently they are oriented the way how I just moved them together, and here we're visualizing proximity within this gap. You can also play with the illumination. What you can also do is you can look at the surface structure of these fragments.
So we've scanned about 280 fragments at Akrotiri, and all told there are about 12 matches in all. That's not very many. And we found 10 of those, I believe. We also found 2 matches the conservators didn't know about.
Which was really exciting. The next morning we went into the lab and we picked up, piece number whatever and piece number whatever and put them together, and sure enough they locked.
We also have a fresco that the conservators made for us in the style of the ancient frescoes, and they simulated an earthquake and then mailed it to us. And so here we have about 130 fragments, and we found that out of 253 matches, we're able to find 175 of them. And that sounds like maybe not so many, except that's already more matches than there are fragments. It's that if you have several fragments that all meet with each other, you may not find every one of the matches, but you still find enough to assemble that whole cluster.
We have demonstrated that the project is worth pursuing.
At the current rate at which they operate, the conservators estimate that they're going to be busy for the next 100 to 150 years.
Having this ability to really exhaustively try everything very quickly can be quite helpful.
We're excited to see whether we can speed up the process.